Hello everyone. So today we are going to talk about isomorphism of graphs. Two graphs G1 and G2 are isomorphic if they are basically the same graph drawn in a different way. Formally speaking, two graphs G1 and G2 are isomorphic if you can find a bijection f from V1, which is the vertex set of G1, to V2, which is the vertex set of G2, so that if two vertices A and B in G1 are adjacent, then FA and FB in G2 are also adjacent, and if A and B are not adjacent, then FA and FB are not adjacent. So basically the bijection preserves the adjacencies and non-adjacencies, and if that happens, then these two graphs are isomorphic. Again, in simpler words, two graphs are isomorphic if they are basically same graph drawn in a different way. So now, given these two graphs, how can we check that they are isomorphic or not? There is a list, an incomplete list. We'll see why it's incomplete later. So what do you need to check? First, check if they have same number of vertices or not. Then check if they have same number of edges or not. Then check the distribution of the degrees. Check some subgraphs, etc. Let's take an example. So these are our two graphs, G1 and G2. So G1 is A, B, C, D, E. G2 is U, V, W, X, Y. Are these two graphs isomorphic? Are they the same graph? Let's see. Number of vertices is 5 in both cases. Number of edges is 5 in both cases. The degree distribution, degree is 2, 2, 2, 2, 2. Here it's also same. So seems like they are bijective, but seems like. To prove that they are isomorphic, we need to provide a bijection between the vertex sets. So between V1 and V2. So let's see. So V1 has A, B, C, D and E. So let's say we map A to U. Then U has two neighbors. Let's take W, which is also, like, B is a neighbor of A. So B goes to W. If we want to mark them, let's do it this way. So this B goes to W, C goes to Y, D goes to V, and E goes to X. So the bijection from V1 to V2 is A to B, A to U, B to W, Y, V and X. So these two graphs are isomorphic. Again, if the number of vertices, number of edges, degree sequence, subgraph, everything is same, to prove that they are isomorphic, you need to show a bijection. A bijection between the two vertex sets is the only proof of isomorphism. Without that, the proof is not complete. So given two graphs, if someone asks you are they isomorphic or not, if you think they are isomorphic, you have to provide a bijection between two vertex sets. Now, we said that the checklist of invariants is incomplete. That means there are no useful set of invariants currently known to us to determine that two graphs are isomorphic or not. Those four invariants mentioned in the handout, if they are same, then the two graphs may be isomorphic. If they are different, they are definitely not isomorphic. But if they are same, all these four invariants, number of vertices, number of edges, degree sequence and subgraph, even if they are same, we cannot guarantee that these two graphs are isomorphic. So the checklist is not complete. The only way to prove two graphs are isomorphic is showing the bijection. Now let's try another example. So this is G1, this is G2, and we are trying to find out whether they are isomorphic or not. So let's go through the checklist. First, the number of vertices. How many vertices are there? 10. How many vertices are here? 10. Next, number of edges. How many edges are there? 9. Here, 9. So far they are all same. Degree sequence 4, 4, 3, and all of them are 1. So 4, 4, 3, then 1, 1, 1, 1, 1. Here 4, 4, 3, rest are 1. So seems like same. Last is subgraph. Now G1 has this subgraph, this H looking subgraph. G2 does not. So we can say that G1 has this subgraph. G2 does not. So what's the verdict? Not isomorphic. So to prove that two graphs are not isomorphic, you have to show some example that is in G1 but not in G2, or it's in G2 but not in G1. Then it's fine, you can show they are not isomorphic. But to show that they are isomorphic, you have to provide a bijection.